हेलो एवरीवन, वेलकम टू अन अकेडमी। आज की इस सेशन को स्टार्ट करने से पहले आई वुड लाइक टू हैव द इनपुट एज वेल एज द कंकरेंस रिगार्डिंग द क्वालिटी ऑफ वीडियो एज वेल एज ऑडियो एंड देन वी आर गोइंग टू स्टार्ट टुडे सेशन। ऑल्दो थंबनेल में कुछ दूसरा डिटेल लिखा हुआ है, लेकिन आज से हम स्टार्ट कर रहे हैं मॉसफेट एसी एनालिसिस। प्रॉब्लम देख के समझ में कैसे आएगा दैट वी हैव बीन टॉकिंग अबाउट द एसी एनालिसिस if in the question they had been focusing over the three important different concepts like voltage gain, current gain, input impedance, output impedance. If these four different parameters have been asked in this given question, keep in mind the problem is been the problem from AC analysis. Yes. Okay, that I'll see as well. So ये clear है आप लोगों को। आज से start कर रहे हैं MOSFET AC analysis. And keep in mind the MOSFET analysis has been utterly important for the two different branch, and that includes electronics and instrumentation. Although the question is also been the part of electrical side as well, क्योंकि electrical में अब MOSFET बहुत prevalent हो गया है. Reason? Because nowadays what happens, the student who have been getting good score in gate, no, either in electrical or instrumentation side, their first branch of preference is still VLSI. Or VLSI is all about MOSFET in DC environment, AC environment, the different parameter calculations like drain current, whether it has been working in saturation or triode region, how much a voltage gain, current gain, input impedance or the output impedance would be offered by the system. So that is what I am saying. Either you have been from either of the branch, electrical, electronics or instrumentation. Now MOS complete analysis has to be there in your mind. There is no other way. There is no other way. तो एक चीज और भी ध्यान देंगे, एडी भाई साहब आप यू वेट अ बिट. Definitely you had asked a certain question and probably that had also been posted over the telegram. I'll have a look on it and definitely I'll get back to you. So better to come with me and also focus over the MOS AC analysis. So we come back to our working board. So the first and foremost important point, how will I get to know that the AC analysis is to be made or the DC analysis is to be made? ठीक. गुड मॉर्निंग पूजा. एसी या डीसी एनालिसिस आपको पता कैसे चलेगा कि आपको करना है? सी, whenever in the question they had been focusing over the current gain, voltage gain, input impedance between certain two terminals, output impedance, by default ये प्रॉब्लम जो है वो एसी एनालिसिस का है. एसी एनालिसिस का है. तो आप लोगों को प्रॉब्लम रीड भी करने आना चाहिए और आपको एग्जैक्टली ये पता भी चलना चाहिए कि प्रॉब्लम में एसी इक्विवेलेंट लेना है सर्किट का, डीसी इक्विवेलेंट लेना है. कुछ प्रॉब्लम्स के थ्रू मैं आप लोगों को ये क्लियर करूंगा तो ज्यादा अच्छे समझ में आएगा. देखिए प्रॉब्लम्स के वैरायटीज कैसे हो सकते हैं. देखिए, गिवन फिगर shows a two stage CMOS amplifier. ये आपके लिए बहुत बड़ा एरिया ऑफ कंसर्न नहीं है, ठीक है. Determine its overall gain. It had been talking about the output versus input voltage. So obvious बात है, ये voltage gain के बारे में बात कर रहा है. We had to take its AC equivalent. Same goes with this question as well. Determine output versus input ratio for the CMOS inverter. Again, it has been a problem of a AC analysis. Let's take another question as well. Determine V naught by V in. Determine V naught divided by V in. This has been a problem which had been experienced in gate electronics 2018. What they had been seeking for? Effective transconductance GM कि input voltage effective कितना current ID withdraw करेगा. Again, it had been a gain, so AC component. See, this has been a problem of gate instrumentation 2019. What they have been seeking for? They have been seeking for the ratio between the output voltage to the input voltage. So keep in mind, whenever you have been dealing with this kind of problem, no, you had to have this thing in your mind. Yes, we had been dealing with AC analysis. Effective transconductance. Again, in this question, the three number of MOSes they have been used, and they had been seeking for the effective transconductance. You can see very well, and these are been the options over here. Options over here. Did you really understood what exactly I wanted to communicate? What happened? Yeah. So till this point, I don't find. Good morning, dear. Good morning. तो यहाँ तक सब लोगों को सब चीजें क्लियर है. How did I actually know that we had been dealing with the AC analysis of the given transistor, or the for the time being it has been MOS? Obviously, sir, अगर voltage gain, current gain, इनपुट इम्पिडेंस, आउटपुट इम्पिडेंस, इन चार पैरामीटर्स के ऊपर बात हुआ, डेफिनेटली वी हैड बीन टॉकिंग अबाउट द एम्प्लीफिकेशन. or I can say effective transconductance, or total transconductance. जनरली आपको करंट गेन के प्रॉब्लम मॉस में देखने को नहीं मिलेंगे, जनरली आई एम सेइंग। क्यों? क्योंकि मॉस गेट से कोई करंट सिंक नहीं करता, क्योंकि बीच में सिलिकॉन डाइऑक्साइड का एक थिक इंसुलेटिंग लेयर होता है जहां से कोई कंडक्शन करंट फ्लो नहीं हो सकता। तो अगर वो आउटपुट करंट और इनपुट करंट का रेशियो पूछते हैं तो इनपुट करंट तो जीरो है, वर्चुअली स्पीकिंग करंट गेन जो है वो इनफाइनाइट हो जाएगा। सो दैट इज व्हाई उनके डिक्शनरी में करंट गेन यूजुअली मॉस में नहीं होता। यू विल गेट दैट गेन इन बीजेटी, बिकॉज बीजेटी से करंट सिंक होता है। So I can say, if you want, you can write somewhere, whenever the problem is being the problem from voltage gain, input impedance, output impedance, and transconductance, by default the problem is being from the AC analysis. Yes, how about engineers? We will have a conversation in both, because I can understand the two students are been more comfortable in English, so definitely I'll have understanding in both. See what had happened. Many of the times we used to have one doubt by visualizing the problem. We easily don't get the thing whether we had to take the AC equivalent of the given circuit or whether we had to take its DC equivalent. See, whenever in the question they had been seeking ID, IS, whether the given MOS has been operating in triode, saturation, or the cutoff mode. This kind of the questions have been a question where I need to take its DC equivalent. What does it mean by the DC equivalent? All of the AC parameters like AC sources would be removed. All of the capacitors would be taken with its reactance, and that is been open circuited. Whereas in the question, if they had been seeking for the parameters like current gain, voltage gain, input impedance, output impedance, effective total transconductance, keep in mind the questions had come from AC analysis. What does it actually mean of the AC analysis? I would take the AC equivalent of the circuit. All of the DC voltage sources, current sources would be removed and will be replaced by its internal resistance. As we know, the voltage source has the internal resistance as 0. So all of the voltage source would be kept short circuited, and all of the current source has its internal impedance as infinity. They would be kept as a open circuited. Same goes with the capacitor. Capacitor C is been taken very large, and hence XC 1 upon 2 pi FC, and that is been kept at short circuit. That is been kept at short circuit. So till this point, I don't find any of the students will have any kind of doubt now. Probably you guys must be able to recall when we were talking about the H parameter model and the RE parameter model. This are been the two model which has been the AC equivalent model of BJT alone, when the BJT has been operating in small signal and low frequency. Could you be able to recall? We had a HI, then we had HRVC, then we had a HFIB. But anyways, that was an electrical model of a BJT when the BJT has been operating in a small signal. What does it mean by the small signal? In compare with the base voltage or the bias voltage, the input bias has been very small. That's been the first important thing. And the second is nothing but the operating frequency of the input signal which has been applied to the given circuit has been very small. So same goes here as well, my dear friend. So now the AC equivalent which we are been deducing for the given NMOS or the PMOS for the time being again had the same condition, that operating input frequency is low in nature, or I can say low frequency, and at the same time the input signal is small in nature. Input signal is small in nature. Has it been clear to all of us? Agreed? Now many of the times I had seen the student had one doubt, sir, why we have been going beyond the frequency and signal strength or the stretch of the signal. My dear friend, see, as the frequency increases, will you agree or not, there are been the capacitive effect here and there, like in between silicon dioxide layer has been filled, the channel may become one plate of the capacitor, gate may become one plate of the capacitor, and as the frequency increases, as you know, the reactance or the impedance offered by the capacitor is been 1 upon 2 pi fc, and as the frequency increases, xc reactance would decrease, and as the reactance would start decreasing, there would be a leakage current between the different layers. It could be in between gate to channel, it could be in between gate to drain, and similarly gate to source as well. So when we will go into the high frequency, there would be the leakage current between the different terminals. And if you really wants to analyze that situation, in that case, its equivalent model would also contain 3 to 4 different numbers of capacitance. There would be the capacitance between gate to, or I can say channel, and similarly gate to drain, then gate to source, and similarly drain to source. So whenever CGD, the capacitance between drain to gate, similarly drain to source capacitance, these are the values are being given in this problem. Keep in mind that problem is not been the problem from a low frequency, that is been the problem from high frequency. But out of 100 question, only one question may come from high frequency, otherwise all of the questions are supposed to come from low frequency. Did you really understood what exactly I wanted to communicate? Now, why we have been so focused over the stretch of the signal? What does it actually mean of it? Probably this part also most of the students don't understand. See what had been happening. See, just try to understand in this way. Let me take a see. See, this complete circuit is being the circuit where this MOS is being forced to operate in saturation region, because the saturation region has been the reason where the BJT had a capacity to amplify the input signal. So this complete circuit is nothing but the circuit where the MOS is forced to work in a saturation region. And here comes the input signal. Here comes the input signal. Just try to understand what exactly I wanted to communicate. See, if input signal has a high frequency, so all the way this signal gets connected to the MOS. And now you yourself would be able to say there had been a capacity effect. And if those capacitors are been working in a high frequency, there would be the leakage current. There would be a leakage current. When that leakage current would be a prevalent or predominant, only and only if the input signal which you had applied, it's been a high frequency. Anyways, many of the students also don't understand, sir, from where this high frequency do come. My dear friend, see, I had a transmitter. Definitely it will have an amplifier, because the vocal signal all the way it comes through this amplifier would be in millivolts or microvolts. So definitely I need this amplifier. So the amplifier is maybe MOS based, BJT based. So obviously there must have been an internal structure or the circuitry which will keep this MOS in amplification region. So whatever the analog signal do come through this wire, it would get amplified and it would get transmitted. So I can say this all the way this signal through wire goes to this system. So this input is nothing but the input of the source. Obviously the length of this wire would carry certain amount of resistance, and that is nothing but the source resistance. So now my frequency, is it been at a higher side or is it been at a lower side, will decide the equivalent of this MOS. This has been a vocal signal. Probably maximum it will fall till the range of 5 kilohertz. You had seen that the human vocal signal cannot go more than 3 kilohertz. So obviously the input signal which I had applied to this circuit has been low in frequency. Did you really understood what I'm saying? Low in frequency. And as it has been low in frequency, obviously I can simply say the MOS, all of the capacity effect has been neglected. Did you understand what exactly I wanted to communicate? Yes. Agreed, no? Now, if I had been keep shouting loud, now there could be a very large in between signals as well. See, I have been talking, okay, I am teaching loudly. I had said something. See what happens if the input signal is too large. What can happen? See, all the way this large signal can disturb its biasing, and as its biasing has been disturbed, probably the given MOS may come from saturation to triode or from saturation to cutoff, and in that case it won't work as an amplifier at all. So what can happen? If you had been applied a large signal, the MOS may not work in an appropriate region where it actually works as an amplifier. So if it goes in saturation, it goes in cutoff region, those part of the signal would not be constructively reflected at the output side. So I would say you will be getting a distorted outcome. Yes, you will be getting a distorted outcome. Did you really understood why we have been concerned about the two important parameters of the input, and that has been the frequency. If the frequency has been very large, the XC will start coming under the effect. The XC would be a very small, and there would be a leakage current. So obviously I don't want to account that effect. So obviously your operating frequency must be small. That's been the first important thing. And the second important thing, the many of the students should also have the doubt, sir, why we have been going behind large and small signal. देखिए मैं पढ़ाऊंगा तो यहाँ हिंदी में, लेकिन दो लर्नर्स जो हैं वो इंग्लिश के हैं, तो मेरे हिसाब से आप लोग कंफर्टेबल होंगे. हिंदी वाले भी एक बार बोल देंगे कंफर्टेबल है ना? यस. So I don't want to disturb my output. So obviously I take the guarantee that the input signal is also been a small signal. So till this point I don't find any of the students would have any kind of doubt now. Agreed, my dear friends? If till this point each and everything has been clear, just write yes sir, then we will move ahead taking its mathematical model. And in the given mathematical model, how do we calculate the value of GM, RD? Those calculations we'll be doing over here. Those calculations we'll be doing over here. So till this point I don't find any of the students would have any kind of doubt. So here comes its equivalent. See, whether you had JFET, E MOSFET, D MOSFET, N channel or P channel, the replacement remains exactly same. I had seen whenever you had a numerical, and if the numerical contains PMOS and NMOS, let's take the two number of PMOSs and the two number of NMOSs, the student starts getting shivering. They used to have a doubt, sir, how do we calculate VGS? Here it was a PMOS, here it was an NMOS, and how the GM VGS will have its flow of current, whether it will be from drain to source or whether it would be a source to drain. Keep in mind, this has been the AC equivalent of any kind of FET, which includes JFET family, which includes both MOSFET family, either it has been a E type, either it has been a D type. But keep in mind, this is valid only and only if the given FET is been operating in a small signal. Virtually speaking, the input source which has been applied to the given FET has to be small in signal, and similarly it should also be low in operating frequency. Agreed? Till this point I don't find any of the students would have any kind of doubt now. What to do now? First you had to identify this three number of terminals. Obviously we had a three number of terminals. The middlemost terminal has been the gate. The terminal which carries the arrow, that has been nothing but the source terminal, and its counterpart is nothing but the drain terminal. So virtually speaking, MOS has a three number of terminal. Physically it has a four number of terminal, but usually bulk or base is been straight away short circuited with the source. So I used to say we had a three number of terminals specifically in MOS. Either it has been an NMOS, either it has been a PMOS. Yes. Agreed till this point I don't find any of the students would have any kind of doubts. My dear friend, I would like to ask from each one of you, would it sink any amount of current? No. Physically we had already seen gate to source there had not been any conduction path, because in between silicon dioxide layer has been filled up, and the silicon dioxide layer is going to be a very high insulating property. Virtually speaking, there could not be any conduction current which can go all the way from gate to channel. Obviously there had been a blockage for the conduction current. So we had been taking its equivalent. No, see, if the current cannot flow, either it has been DC current, either it has been AC current, it can't flow. It's as simple as this. So that is what we do. In between gate to source, in AC equivalent, it is being treated as an open circuit. Why? Because the gate cannot sink any amount of current. Whereas in case of RE and H parameter, we had HIE or RPI. Why? Because in case of BJT, when we were trying to keep the BJT in amplification region, we were keeping BJT in active region. And while keeping BJT in active region, base to emitter junction were kept in forward bias. And as the junction has been kept in a forward bias, its effective resistance would be very small, maybe in 1.1 kilos to 1.8 kilos, 2 kilos. That is why the effective resistance is being taken as a RPI, and the RPI was calculated using the DC analysis. But that has been the basic difference. See, you should not think that the equivalent of BJT, equivalent of FET is nothing to do with each other. You had to have a little bit conceptual clarity as well as relationship between them. Why the RPI is being used and why the open circuited is being used, because constructionally BJT as well as FET has been quite different. BJT as an amplifier works in a active region, and their base to emitter terminal has been a forward bias. So obviously we will be having a input resistance over there. But in case of FET as amplifier, we will be keeping it in saturation region, and obviously it will not sink any amount of current. And one thing has been quite clear, my dear friends, solving the problem related to the MOS has been much easy than the BJT. Why? Because in BJT we were applying the input loop because we had RPI, but once you'll apply the input loop, you yourself would be able to understand there had not been any current which can flow in the input side. Only voltage is going to decide the output current, and hence the calculation becomes much easy. Agree? Now you must have seen this fact. Now the input voltage difference between the gate to source terminal, I may write this as a VGS, is been deciding the output current. So the input voltage is been controlling the output current. So here this has been a case of voltage controlled current source. In case of BJT, we had beta times of IB, and here we had a IB current, or the current through the base terminal. So here this kind of source was current controlled current source. And now the factor which will control the output current is being called as a GM, and that is nothing but the transconductance of the given MOSFET. And the unit is going to be of milliampere per volt. If you want to write SI, it is going to be of ampere per volt. Why? Because voltage is deciding the current. Voltage has to be converted in a form of current, and that is possible only if the voltage has been multiplied with MOS. Virtually speaking, it has been multiplied with the transconductance. So may I know what is going to be the unit of it? I can write this as a ohm inverse. Even I can write this as a mho. And Siemens is also been another way to write or represent mho now. Has it been clear to all of us? Till this point, I don't find any of the students should have any kind of doubt now. And similarly, R0 is called the output drain to source resistance. Output drain to source resistance. Obviously, the value is supposed to be in ohms, but practically it is been very large, usually seen in mega ohms. See, most of the questions which would be asked from FET side AC analysis, the value of R0 is not been given. And as the value of R0 is not been given, and you can see its value falls in a very large way, so we take this as an open circuit. So I will also use this circuit replacement with the wave FET, but I won't use R0 only. Yes, VGS will remain VGS, and now this current source will remain as it is, only and only R0 will be removed over here. The next important point, from where you will be getting the value of GM and the value of R0. These two parameters would be calculated by doing the DC analysis, as we did in case of RE parameter. Are you be able to remember it? While the RE parameter, the value of R pi, the input base to emitter resistance, was calculated with, are you been able to remember? And that is been beta plus 1 into RE, and RE is been VT divided by IB. So what we had to do, we had to do the DC analysis, we had to get the value of GM, and then we had to get the value of R0, and with the help of these two important parameters, easily we can get the voltage gain, current gain, input impedance, output impedance. Let me go forward, taking the new slide. See, in saturation region, are you be able to recall what was the current equation where the ID and VGS has been connected to each other? And this was ID is equals to or drain current ID is equals to half times of mobility of n channel capacitance per unit area of silicon dioxide layer, width versus length or the aspect ratio of the channel, and here comes VGS, and that is being the potential difference between the gate to source terminal minus threshold voltage, the minimum required VGS to get a deep inversion from where onwards the current starts, and here goes to the power of 2. Here goes to the power of 2. Here goes to the power of 2. Till this point, I don't find any of the students would have any kind of doubt. See, we will try to understand what has been the GM over here. What has been the GM over here? The GM is been a parameter which gives you an example how effectively rate of change in VGS is reflected in a form of ID, because VGS is been a parameter which has been controlling your output current. So definitely this has been a right time to analyze how effectively the output current is going to get affected because of the change in input voltage, and that relationship and that what should I say, that bridge is been filled by transconductance. So why the transconductance is so important? Because the transconductance has been a parameter which gives you an idea the rate of change in VGS, how effectively it changes the value of ID. So obviously it has been the most important parameter, at least while we do AC analysis. So what to do now? What to do now? So we have been focusing over the rate of change in ID over VGS. And wherever we talk about the rate of change, obviously we had been talking about the AC analysis, because in AC we will be having a continuous signal which will be increasing its voltage as well as current. So I want to know if VGS is being changed at this bit, how much the ID is supposed to change. So here I had been talking about the rate of change. Here I had been talking about the rate of change. Yes. So here comes, you see, this complete parameter remains as it is, and that is why it is also been called as a process parameter, because once the MOS is constructed, this value is not supposed to vary from its place. And why deliberately I had taken VGS? Because obviously, sorry, why we had taken a partial differentiation? Because ID had a little bit effect from the VDS as well, but that factor has been nullified for the time being. So what happens? The 2 comes out, 2 comes out. Yes, 2 comes out, and we will be left out with a VGS minus VTH. And obviously again we will take the partial differentiation. VTH has been a constant, and this remain your value. This remain your value. One of the important outcome. One of the important outcome. See, if you want, you can cancel this 2 and 2, and so the factor which you get, this has been a very important factor which we had calculated over here. It's been a very important factor which we had calculated over here. So whenever the question has been given, what to do now? First you have to do the DC analysis. In DC analysis, obviously baat hai, process parameter would be clearly given to you. VTH must have been clearly given to you. You had to check it out whether the given MOS has been operating in a saturation region or not. You had to find VG and then VS, and then you have to subtract them together. VGS, you have to feed this data, and once you feed this data you get the value of GM, and once you get this value of GM, probably now you have been ready to do its AC analysis as well. Agreed what I'm saying? Till this point I don't find any of the students would have any kind of doubt now. Nobody should have any kind of doubt now. So till this point I don't find any of the students would have any kind of doubt now. So till this point each and everything has been clear or not? I would like to have the input from each one of you, and then we will move forward taking the next concept as well. Yes. So till this point nobody should have any kind of doubt now. If you want, even you can relate this GM with ID as well. What I'm saying, if you had a plan, you can relate this component with the ID as well. If you want, I can relate it well, but for the time being, I'm not keeping as it is. I'm keeping as it is. Agreed? We can do one more thing. See, VGS minus of VTH to the power of 2. I could have kept this all component towards right hand side. This must have been VGS minus of VTH is equals to now the square goes towards this side and this becomes 2 times of ID. This 2 had gone towards this side, and here comes mu n CUX W by L ratio. Yes, I can feed this data over here. See, VGS minus of VTH would be kept with that value. So here it goes. See, 2 times of ID. Yes, and now this component and this component goes out, and here we will be kept with the mu n CUX and W by L ratio. So this is the different way to write the GM, because what happens whenever we will be doing the DC analysis now, usually we will be getting the value of ID, and once we get the value of ID, easily we can get the value of GM as well. Agreed? So it has been completely dependent on you. Anyways, there have been a lot to talk, but I'll constrain myself taking very complex analysis, at least at very first class of the AC analysis of the MOSFET. So straight away we take few number of numericals. We will try to learn how to apply the concept which we had digested over here. So about engineer, are you been there? AD, are you been there? एक बार आप लोग मेरे को फटाफट बता दें, उसके बाद मैं स्टार्ट करता हूँ, बिकॉज मैं आप लोगों के कारण ही इंग्लिश बोल रहा हूँ. I had been speaking to you guys with English because this channel has been meant for the Hindi communication. I will switch it to the Hindi. So just make me sure that you guys have been there, so that I will be continuing in English itself. Tell me. Yes, sir. Okay, great. Now let me talk about the GM a bit. Let me talk about the GM a bit. For that, I had taken the transconductance curve. This curve I would call be it transconductance curve. Because in one frame I had taken the voltage difference between gate to source, whereas in another frame I have taken the drain current ID. As you guys have been well aware, in saturation region, ID and VGS is being connected with this square law. What does it mean by the square law? You must have seen this kind of structure in mathematics. Is also been called as a parabolic. Yes, parabolic. How did I know it has been parabolic? Let's take this as being the component at y, and obviously VGS has been a component at x. So y is equals to x square. Which kind of the curve it had been? It has been upper facing parabola, which has been shifted at VTH. So that is what I have been doing over here. So it is going to be upper facing parabola till VTH, and thereafter you will be having this kind of curve. So when we will connect the output drain current to the input gate to source voltage, this kind of the curve we are going to have. And keep in mind, this curve would be valid only and only if the given transistor has been on and it's been on in saturation region. Now many of the students would have one doubt, sir, why we have been going behind this curve, why it has been so important. My dear friend, the slope of this curve is nothing but GM, and the GM is going to decide what would be the gain which will be offered by the given MOS. See, GM, how the GM has been defined? The GM has been defined as a rate of change in ID over the VGS, rate of change in Y with respect to the X. And you can see very well the Y axis has been dedicated towards ID and the X axis has been dedicated towards the VGS. I would like to know from each one of you, as the value of VGS increases, you yourself would be able to understand whether the things have been going fine or not. Where the slope has been more? The slope is nothing but the slipperiness. If I will force you to stand over here, where you will be finding more slippery, obviously is this point, the slippery or the slope increases. Why the slope has been increases? Somebody can tell me? Yes, because as you have been going towards right hand side, not only the value of Y component, even the value of X component is also been increasing. If you compare with this point to this point, This has been keep shifting towards right hand side, and same time it is also been going towards upside. So one important conclusion which we can deduce out of it, the value of ID is also been increasing and the value of VGS also been increasing. Virtually speaking, the slipperiness slope GM will increase with the increase of VGS as well as ID, and that we had already calculated, my dear friend. This has been GM. What has been GM? GM is nothing but the slope or the slipperiness of this equation, and you yourself would be able to understand the slipperiness is been keep increasing with the VGS. As the value of VGS will increase, this component will increase and this GM will increase. Agreed? And at the same time, even the GM is also been connected with the ID as well, because the VGS and ID is been connected. So you can write in either of the way you want. The way you want. Is it been clear to this point? So obviously the GM is also been connected with the ID. It is not been linearly connected. If GM must have been linearly connected with the ID, the curve must have been a straight line, but this has not been the case. This is not been the case. So I can say as the value of VGS increases, the value of GM will increase, and as the value of GM will increase, the little bit change in VGS effectively will change the value of ID. Effectively change the value of ID. Yes, the different values of VDS will change this curve a bit, but I take a situation where the GM is being calculated taking a circumstances that the VDS is being taken as a constant. Anyways, you don't have to write it separately. Why, sir? Because already the partial differentiation has been taken place. Virtually speaking, I want to calculate the rate of change in ID where the VGS is being changed, whereas the remaining parameters are being kept constant. Has it been clear till this point? I don't find any of the students would have any kind of doubt at this point. No, sir. Nobody had the doubt, sir. Quite great, sir. Quite great. So GM निकालना मुझे लगता है कि now you guys are been well aware कि GM, how do we calculate the value of GM? Yes, agreed till this point. So let me talk about the R0 as well. Anyways, the R0 is been output impedance between drain to source. So my basic focus point would be output characteristic. Anyways, as we say the output characteristics, the two electrical parameters we are going to connect at output, that has been output voltage. Let's take that has been VDS in case of common source, and similarly output current, and that would come across ID, drain current. When the transistor is been on, the curve is been found in this way. See, curve has been found in this way. So ideally this used to be the curve over here. This has been a different values of VGS. Let's take it's been a VGS1. Here the potential difference between gate to source has been changed to the VGS2. Theoretically we find the relationship between the output voltage VDS versus ID has been kind of this, but practically it has been a bit different, and you get a slope as well. See, you get a slope as well. What does it actually mean of it, my dear friend? My dear friend, the green slope was 0, and the green slope talks about the rate of change in ID because of rate of change in VDS. For green curve, the slope itself was 0. And may I know what was its slope? The slope is nothing but the reciprocal of the output impedance. Why? Because Y we had been treating with the current, X we had been treating with the voltage. So Y versus X, current versus voltage, will make it more. So obviously it is going to be the reciprocal of the output. And as you can see, once we'll be compare them together, the RD has been found as infinity. Virtually speaking, if this has been the case, when the output characteristic has been a flat in saturation region, RD must be removed from its equivalent circuit. RD must be removed in its equivalent circuit. Yes, I could have RD or R0. I could have just knocked off out. But many of the times the channel length modulation effect also they do consider. Practically speaking, we get a little bit flattened structure. So what to do now, sir? Now you can't say, sir, the RD 1 upon RD is being 0. It has been a finite value. And as it has been a finite value, RD is also been a finite value. And as the RD has been a finite value, when we will be taking its AC equivalent, we also had to introduce the value of RD. We can't keep RD as infinity. Great, sir. That part we had not shown CFA. So what to do now? So we have to talk about the exact equation of the current, what it used to be. See, so far ID and VGS relationship, what we had taken, no, it has been bit different practically. Anyways, half times of mu n cux aspect ratio would remain as it is, Here we will be having vgs minus of vth raised to the power of 2. That would also be the same, but here comes 1 plus lambda vds. VDS has been very clear, and that has been nothing but the drain to source potential difference. Lambda is also called a channel length modulation effect. May you know what would be its unit? See, 1 has been a unitless quantity. Can we add 1 kilometer with the 1 kilogram? No, we can't. 1 has been mass, 1 has been length. So same, can we add a unitless quantity with a quantity which has a unit? No, obviously we can't. So 1 can be added with a unitless quantity only. The value of, or the unit of VDS is been volt. So obviously the unit of lambda has to be volt inverse. Then only their unit would get smashed, they would be just neutralized, and now a unitless quantity can be added with a unitless quantity. So many of the times lambda is been supplied. Many means out of 100, merely I am saying 2 or 3 times. The lambda is been supplied, and whenever the lambda is been supplied, keep in mind, I repeat, keep in mind, you have to feed the data over here and you have to get the value of RD as well. My dear friend, so one important assumption. Whenever the lambda is not been given, or it has been said channel length modulation has been neglected. Channel length modulation. The channel length gets modulated with respect to the VDS. That has not been the part of analog that we used to study in analog. Devices. Channel length modulation neglected. Channel length modulation neglected. And whenever the channel length modulation neglected, my dear friend, the lambda has been taken as 0. Why lambda has been taken 0? My dear friend, if lambda has been taken 0, this component goes out. And this equation of the current remains the same equation which we had been using so far. So here comes the ID is equals to half times of mu n cux wl ratio VGS minus of VTH raised to the power of 2, and here comes 1 plus lambda VDS as well. 1 plus lambda VDS as well. Now what we will do over here, my basic intention is to differentiate ID with respect to the VDS, because which will give you the little bit idea. So here comes, see, we will take its differentiation. Once we'll take its differentiation, what had been happening in this complete component, nowhere the VDS exists. So this component will remain as it is. Agreed? Straight away, what happens? The differentiation of the VDS takes place. So here it becomes lambda, and approximately we can take this as ID. Yes or no? Okay, I'll take that as well. AD, I'll take that as well. So from here I can at least say the what R0 or RD is going to be, see, once you'll take its differentiation, only the differentiation will take place over here, and it becomes lambda times of ID. Yes. Sorry. Once you'll take differentiation with respect to the IDS, it would be 1 upon R0. No, it would be 1 upon R0. 1 upon R0. So I can say R0 is supposed to be 1 upon lambda into ID. So here it be voltage inverse. Voltage inverse would go towards upside. Voltage divided by current will make it resistance now. Has it been clear till this point? I would like to have the input from each one of you. Till this point, each and everything has been clear or not? AD, Swami, AD, what has been your good name, dear? So let me check my Telegram channel as well. Eddie, check once again. Had you given the reply over a Telegram channel where it has been written as a Sonal circuit, or had been applied somewhere else? Because I am not able to see your comment, and it's been a channel. You can just make certain. See what I have been telling. Please Send your doubts. You can reply on this channel because dedicated you can not tell me. Yeah, my Telegram link has been t.me Sonal Circuit. Yes, this one. T.me Sonal Circuit. Tell me which was your question. And I would request to each one of you, you also follow me on Telegram. Oh, sorry, Unacademy special class. You write Sonal Circuit because I used to take the 3 different kinds of class. One class would be dedicated over the tab itself. I would take the complete class in tab only. So Sonal sir, not Sonal sir actually, Sonal Kumar Agrawal. And you start following me. Today also we are going to have the class over there, which won't be streamed over the YouTube. Sir, in Sonal sir gate channel only I have posted in discussion part. Okay, okay. Sir, for this circuit, yesterday I have asked you to explain it of which feedback topology and what feedback element in the circuit. Okay, no issue. We will take that as well. See, we will be taking this as well. So as per the Mr. AD, what has been your name, my dear? So as per the AD, this circuit has been provided by him. Here comes the emitter resistance, and obviously it has been a common base. So the input itself would be applied across the emitter terminal. Here comes Vi. Here comes Re. Then comes gets grounded, and then comes RC, and here the output voltage V0 has been taken, and this has been the external biasing voltage VCC. Ravi, okay, okay. Ravi, from which particular state you belongs from? Andhra Pradesh, Telangana, or somewhere else? And what about Swami? Swami is from Andhra Pradesh. Okay, Andhra Pradesh. Anantapur, no? Yes. Anyways, Ravi, as it had been communicated in the last class, my dear, always we will be taking its AC equivalent. Then only we will be able to find whether there had been a feedback or not. And if there had been a feedback, which kind of the feedback? See, if there had not been any feedback, the classification itself is unjustifiable. You had to have a feedback. For that, we have been taking its AC equivalent. So according to Ravi, he has been asking, taking the reference of this question, sir, whether this circuit carries the feedback. If it has been yes, which kind of the feedback it had been? Great, dear, great. Telangana. Yes. I'd also been there at Andhra Pradesh, sorry, Hyderabad for the 1 year. Because I was working in BARC, Bhabha Atomic Research Center for the 5 years. And now the BARC also have one unit there in ECL Crossroad. ECL Crossroad. Yes, NFC, Nuclear Fuel Complex. So I had been frequently there for the meeting and all. Yes. I would say first do its AC analysis. What I'm saying, first do its AC analysis. Just a minute. It has been RE, it has been VI, it has been RC, and it has been V0. Ravi, now the question goes to or goes back to you itself. Tell me whether this circuit carries the feedback or not. Whether this circuit carries the feedback or not. I had just taken its AC equivalent. What I did, the emitter has been kept towards left hand side. Why? Because it has been a factorial input. The base has been a common in both sides, and now here comes the collector. Whether this circuit carries the feedback or not, I would like to know from you. Whether this circuit carries the feedback or not. That you tell me. No, it does not carry any feedback at all. Because you can see the input as well as the output was quite isolated. The input as well as the output. Yes. No. That's what I'm saying. No. That's what I'm saying. Until and unless you don't take its AC equivalent, you won't be able to position to say something. I taken its AC equivalent. Now RE has been a completely part of input, and similarly RC has been a complete part of output. So I would say there has not been any feedback at all. Yes. And Ravi, more important thing. Many of the times what we do, we deal the given circuit as a common emitter all the time, whether it has been a common base, common emitter. In that case, what would happen? Now you can say, yes sir, RE has been a part of its input as well as output. But when this has been a case, when you have been forcibly using this circuit operating in a common emitter, did you really understood what exactly I wanted to communicate? In that case, you'll say, yes sir, the input current has been flowing through the RE, this has been, and similarly the output current is also been flowing through the RE, and in that time it is going to be a kind of current series feedback. But nowhere this kind of the question would be asked, and if they would be asked, obviously you'll take its AC equivalent and you say there had not been any single element which might be bringing the feedback from output to the input side. There had not been any sampling point, there had not been any mixing point. Has it been clear? Ravi, has it been clear? But if you forcibly wants to analyze this circuit as a common emitter, then you can say this current loop and this current loop would be falling through the RE, and I can say it has been a kind of current series feedback. Because many times it happens. So many times what you'll do, you'll take its AC equivalent and you'll be keeping HFE, although it has been a common base, and that we can do. We had already studied about it in earlier classes. In that case, we can do this also. So Ravi, dear Ravi, has it been clear, my dear? So we will switch off our class here itself, and evening daily basis you guys have to be available, no? Daily basis at 8 p.m. we used to take the classes, and mostly the questions are been supposed to come in ISRO examination. Yes. AD, I'll do that as well. So that's been the great thing which you had started using this channel, no? Definitely when I feel little bit exciting when the students are been, they have been very quite easy questions. Probably one question has been a question, okay, quite easy, filter, and the second problem has been the problem from a voltage shunt regulator. So we'll take those questions as well. I had seen that. So we will knock this class off over here itself, and I would request to each one of you, this concept which we had taught in today's class, have a little bit idea about it in tomorrow's class. Let me save this file as MOS amplifier. Ravi and Swami, the way I had been communicating in English is been comfortable? Because as you guys have been following me in regular basis, definitely I must have a little bit feedback from you guys as well. Okay, so we will breach our class here itself, and we'll meet tomorrow. Till then, bye bye. Tomorrow means we will also be having classes in evening as well, and I would request to each one of you install the Unacademy application, because while installing the Unacademy application, you can also